Okay, welcome back to the second half of 5.5, Law of Signs, looking at what we call the ambiguous case, the ASS version or the SSA, whichever one you feel more comfortable with. All right, so in the ambiguous case, if you're given something along the lines of a triangle like this, 7, 6, and 30. Now, it looks like this is the only triangle that's possible. But the problem is it's not necessarily the case. And it all deals with like the height and the comparison between these two sides, or the comparison of the height and these two sides. What you're going to end up getting is maybe this is the only triangle that exists with 7, 6, and 30 in this order. Or maybe there's two triangles where this 6 is actually long enough. It's a little bit longer than the height, but it's less than this 7, where it could swing. It would swing down below here, and it would end up over here. There are variations like that. That way we could have this green triangle, the first one that I drew, or you could have the one where I just put in this red, where it's got this 7, this 6, and this angle 30 over here. Or everybody's favorite is maybe this triangle can't actually physically exist. Maybe the height is 8. If the height was 8, then the 6 wouldn't be long enough to reach the bottom, and it would just kind of dangle here if this was 6, and it can't reach the bottom. Anywhere it floats, it's not going to ever reach the bottom. Now, I always talk about this visually because people can see it visually. I wish I had a three-dimensional object, but I don't really have. All right, so if you're given the SSA, the ambiguous case, you can get either no triangle existing, and that's everybody's favorite, but you still have to do some work. You have to do a little bit of work to just determine if that triangle exists. And there's only one case where that doesn't work. And you could get one triangle existing, being that was the only triangle you could draw. Or, like I just said, you can get two triangles that exist. And as I mentioned, I'm just writing this stuff out here. It all depends on the sizes of the given pieces, and it also has to do with the value of the height. All right, so you need to remember that the height of your triangle was little b sine of a. That's how we find the height. And here we go. I know this is a lot of stuff, and this is another one of those spots where I just heard you all groan because a lot of stuff just got put up on the screen. But there's 6 variations that occur when you're given the ASS version. And what I want to point out to you is the first 4 variations. The first 4 variations occur when A is an acute angle, and the last 2 occur when A is obtuse. Now, everybody likes this one. If A is an obtuse angle, and the side opposite angle A is less than the other given side, less than or equal to, by the way, then no triangles exist. Oh, I lied. I forgot there's 2 versions of the no triangles. Then no triangles exist. Or the other version that everybody likes is if A is acute and A is less than the height. And I mentioned that option earlier. Then no triangles exist. And go through here and copy this down so you guys know what's coming up here. Your 4 variations for A is acute and 2 variations for A is obtuse. I'm not going to be giving you a handout on this, so you're going to need to be able to write this down and be able to use these from your notes. And notice it all has to be doing with given an angle, given the side opposite, and one of the other sides. So basically you're given angle A, little b, and h, or you're finding h. Now, not all the times do they give you a, little a, and b. Maybe they'll say angle C, and little a. Well, you can still find the height. Now, it just means that you're given the angle, the side opposite, and one of the other two sides. All right? All of the properties still, all of these things still work. They don't have to be A and B. We just simplify it down to just saying A and B. All right, let's look at a couple examples here. I want to determine the number of triangles, and I want you to solve the triangle. And we're not going to solve all of them, but at least one of them. Now, in this case, A is 7, B is 6, and A equals, big A is 26.3. So if I was to just draw a random triangle, and I was to randomly put these in places, I would say this is 26.3. I would say this is 7 and this is 6. Well, I'm given an acute angle. So this is acute, obviously. So I need to look at the 4 variations. That limits me down from 6 to 4. And then I need to look. Well, the first two things, compare it to h. So let's find h. h is equal to 6 times the sine of 26.3, which is approximately, I did have on my calculator, but I got rid of it, 6 sine of 26.3 is 2.66. Now you look at the first one. Is A less than h? Nope. That means that one's gone. Is A equal to h? No, that means that one's gone. Then you're just looking for, is A bigger than B? Oh, sure enough, A is bigger than B, so I didn't even need to find the height, if you saw that right away. A is bigger than B, that means there is only one triangle, and this is the only triangle that exists. And this goes back to just solving the law of sines. Sine of 26.3 over 7 is sine of B over 6. Nice and easy, straightforward. All right, but what about, I'm not going to solve this one. I'm going to solve the next one as we come up to it. What about this one? So we had one triangle for that. What if I was to change things around a little bit? A is 6, B is 7, and A is 30 degrees. Well, now A is not bigger than B, so that one goes out the window, the one we just had. And I should probably find H. H is, let's see, 7 times the sine of 30. Well, I don't need a calculator for this one because sine of 30 is 1/2. So it's 7/2, which is 3.5. Is A smaller than H? No, that means there's at least one triangle. There's either one or two, so we got to figure this out. Does A equal H? No. Is A bigger than B? No. Oh, that kind of looks like it's going to be a 2-triangle problem. Well, let's think about that. Is H less than A, which is less than B? 3.5, less than 6, less than 7. That's a true statement. That means there are 2 triangles. Now I'm going to solve this triangle on the next page. So we're going to come back to this problem in a moment. But finding that there were 2 triangles, that was really an important piece, the first important piece. All right, what's the next one? A is 2, B is 7, A is 36 degrees. So coming up here, A, 36, little a is 2, little b is 7. Let's figure this out. All right, so is A bigger than B? Nope. Is A less than B? Yeah, but that doesn't really help me. Is A less than H? I don't know yet. H is equal to 7 sine of 36. So 7 sine of 36 is equal to 4.11. Well, 4.11 is bigger than 2, which means A is less than H, which means, yay, we're done with this one. No triangle exists. All right, so let's move back to this triangle, the 2-triangle case. And I want to draw the two different triangles. So we're going to get this case here, 6, 7, 30. But we're also going to get this case, where this is talking about where I swing this 6 back over here. So we're going to get this case right here as well. And what you need to notice is, let's call this A, B, and C. Let's call this A, B prime, and C prime, because they're not the same B value. But what I do want you to point out, and I'm going to write this up here, B plus B prime equals, can anybody beat me to it? B plus B prime is equal to 180 degrees. Now here's the reason for that. Is if I was to draw this triangle a little bit better, maybe I'd draw it a little bit nicer here. And I had this 6. If I was able to swing this side over and create this line right here, which is this new line here, this is also 6. And this was angle B, and this angle here is B prime. Now, if you remember your isosceles triangles, 6, 6, and something, this angle here is also B, as this angle is B, which means angle B and angle B prime have to sum to 180 over here. So this is very important that you understand this, because you're going to use this information to solve the triangles. All right, let's get rid of this here. Let's see if we can solve what we need to solve. All right, so on this triangle, oops, sine of 30 over 6 is equal to sine of B over 7. It's the only thing I can solve for first. And doing a little bit of math here, obviously, sine inverse, B is equal to sine inverse of 7 sine of 30 over 6, which is approximately, I think I have this one on my calculator still, 35.69 degrees. And you got to remember that I'm going to use this exact value to help me find angle C. So I'm going to do angle C is 180 minus 30 minus angle B, which is approximately 180 minus 30 minus answer. You get 114.31. And here we got to figure this out. Okay, so that's my angles. Now we got to figure out my missing side, and we're just going to use the law of sines again. And we're going to say that, let's see, what are we doing here? Sine of big C over, actually under little c. I don't want to use a whole bunch of rounded values. I'm not actually going to reuse the rounded value here. I'm going to use the exact. Equals 6 over sine of 30. So little c is going to equal 6 times sine of c. So 6 sine of answer divided by sine of 30, and I get 10.94. And what you'll notice is that once you figure out the first triangle, the second triangle is pretty easy, because you already know that angle B was 35.69. And again, I'm going to use that exact value because I need to do 180 minus that number to figure out that this is now the obtuse angle, 144.31, which means I can do 180 minus that number minus 30 to figure out that this little itty bitty angle up here is 5.69 degrees. And I could do a very simple law of sines to say c over sine of c is equal to 6 over sine of 30. So little c is, hopefully this comes out correct. Every once in a while things come out wrong. let's see, 6 sine of answer divided by sine of 30. And it looks like I get 1.19. And here's where you got to pay attention to what you're doing. Do these triangles make sense? So is the largest angle across from the largest side? C is 114 across from 10.9. The smallest angle being across from the smallest side. Looks like everything kind of lays out correctly here. So you just got to be careful. You got to remember that if you try to do sine inverse, of a number and you get a negative angle, that actually means you're supposed to be in quadrant 2, which means it's an obtuse. So if you do sine inverse and you get a negative angle, it's not actually a negative angle inside a triangle. It's actually supposed to be the obtuse angle in quadrant 2. So be very careful with that. That's actually it. This is kind of a shorter video here. It's meant to be. So have fun with this. I will see you guys tomorrow.